So Unit 3, the two main topics we're going to talk about in Unit 3 is inductive reasoning and deductive reasoning. Now, this unit is going to be a little bit different than what you've seen in past math courses, and it's mainly because we're not going to do just a whole bunch of algebra type math. We're going to be doing more logic based math with this unit. So let's get started with just a couple basic definitions for section 3.1. So first up is this idea of inductive reasoning. Okay, so we open up our tab here for inductive reasoning. And our definition for inductive reasoning is going to be making conclusions based on observations. Okay, so we'll kind of see the difference between inductive reasoning and deductive reasoning in just a little bit. But it's basically like there's no fact that I'm given, there's no rule that I'm following. I'm just observing something and I'm going to make a conclusion based off of that. Okay, so a couple examples that we see over here, a couple math examples. So first we're given a sequence of numbers. Okay, so we're given 160, negative 80, 40, negative 20, and 10. Okay, so we see a pattern of numbers right there. And so as we're looking through, we're going to try to figure out what the pattern is and then also describe what the next term will be. So if I'm looking from 160 to negative 80, I know that I'm getting smaller, but also that, notice that I'm going positive to negative. And then if I go from negative 80 to 40, again, my number is getting smaller, and I change from negative to positive, 40 to negative 20, negative 20 to 10. Well, if I type this into my calculator, how do I get from 160 to negative 80? I get there by dividing by negative 2. And then the same thing happens from negative 80 to 40. Again, negative 80 divided by negative 2 will give me 40, and so on and so forth. 40 to negative 20, I get there by dividing by negative 2. Negative 20 divided by negative 2 will give me 10, and so on and so forth. So it seems like the pattern that I'm following here is I have to divide by negative 2. Now to get from 10 divided by negative 2, my next term would be negative 5 in that pattern. Okay, here's another pattern. Okay, so this one we're not dealing with numbers, but dealing with shapes. So I'm given a triangle, a square, and a pentagon. Okay, so one thing you might notice, triangle has got 3 sides, square has got 4 sides, pentagon has got 5 sides. So each shape we're going up a side. So then it stands to reason that my next shape would be a 6-sided shape, which will be a hexagon. Okay, so that's inductive reasoning. Okay, now inductive reasoning, we can think about this not only in a mathematical sense, like we saw right here with a pattern of numbers or a pattern of shapes, but you could also see it in a real world setting as well. For example, one example of inductive reasoning could be that I know that an NFL football game is going to last 4 15-minute quarters because the game that I went to last week was set up that way. Okay, so I wasn't given any kind of rule book or anything. I was just told, or I was not told. I just observed that the football game was played in 4 15-minute quarters. And so that was me making an observation using inductive reasoning. Okay, so now let's talk about the second type of reasoning that we'll talk about, deductive reasoning. So where inductive was make conclusion based on observations. Let me open up the second one. Deductive reasoning is going to be making a conclusion based on facts. So this is going to be that I have some kind of a fact, some kind of a rule that I'm following whenever I'm making my conclusion here. So in my example right here, I see that if two numbers are odd, then their sum is even. Okay, so that first line right there, that's like my rule. That's what I'm having to follow here. Okay, that's 100% true 100% of the time. So using that rule, I'm given the numbers 3 and 11. Okay, and the conclusion based off those numbers and this rule is that their sum must be even. Okay, so if two numbers are odd, then their sum is even. 3 and 11 are both odd numbers, and if we add them together, we know that we get 14. So this is indeed considered a valid statement because we followed our rule right here, and we saw that when we went through our rule that our conclusion was going to be valid. Okay, so again, deductive reasoning can be used in a mathematical context, or it could be used in a non-mathematical context. Okay, so I'm going to use the same example I used earlier. So this time I'm going to reword it a little bit to where it sounds like it's deductive reasoning. Okay, so now I can say, I know that an NFL football game is split into 4 15-minute quarters because that's what the official NFL handbook states. Okay, so with inductive reasoning, I was making a conclusion based off an observation, based off something that I noticed. But with deductive reasoning, there's some kind of a fact, some kind of a rule somewhere that we have to follow in order for us to make a conclusion. Okay, so with this example, I had to be given that top line, which is my rule, that if two numbers are odd, then their sum is going to be even. So then through there, I was able to deduce that the sum of 3 and 11 would indeed be an even number. And so that's kind of the difference between using inductive and deductive reasoning. So now let's talk about two more terms that you'll see pop up a decent bit in Unit 3. Okay, so this next one is a conjecture. So a conjecture is going to be kind of similar to a hypothesis in science. Okay, so it's kind of like an educated guess. So if we look over in our example, okay, so we are asked to make a conjecture based on the given information and then draw a figure to illustrate our conjecture. Okay, so our conjecture is that angles 1 and angles 2 are vertical angles. Okay, so we've talked about vertical angles a little bit so far. Okay, so vertical angles are created by intersecting lines. They are two non-adjacent angles that are created by intersecting lines. So that's what my picture is right here. Okay, so that's us drawing a figure, but that's not us making a conjecture just yet. We have to make a conjecture or an educated guess. So basically what we're doing is we're looking at the statement that we're given, that angle 1 and angle 2 are vertical angles, and we're going to infer or imply something else based off that. Well, if we recall from our definition of vertical angles, we learned that vertical angles are actually equal to one another. So that can be a conjecture that I could make. So my conjecture will be right here. Angle 1 is equal to angle 2. And then this figure right here illustrates that conjecture. Okay, because not only does it illustrate vertical angles, but also since we already know that vertical angles are equal to one another, this picture is also illustrating angles that are equal to one another. Okay, and the last term we'll talk about is a counterexample. Okay, so a counterexample is going to be an example that proves a statement is false. Okay, so let's look at our example. We need to give a counterexample to show that this conjecture is false. So I am given that angles 1 and 2 are adjacent angles. Okay, and then based off just that information, my educated guess is that angles 1 and 2 will form a linear pair. Okay, so angles 1 and 2 are adjacent angles, and then my conjecture is that angles 1 and 2 will form a linear pair. So with this conjecture, or with the counterexample, excuse me. So if I'm trying to think of a counterexample to this conjecture, all I have to do, I have to obey my given statement. Okay, so this first statement, angles 1 and 2 are adjacent angles. I have to follow that statement. But I'm trying to disprove my conjecture. Okay, so my conjecture being that if I have two angles that are adjacent, the only option is that they must form a linear pair. Well, I'm going to come down here and I'm going to draw a picture. Okay, so in this picture, I see angles 1 and 2. Okay, they are two angles that are adjacent to one another. They are both right next to each other. They share this middle ray. But as you can see, angles 1 and 2 do not form a linear pair. They form a right angle. These angles are complementary to one another. So because I obeyed my given but disobeyed my conjecture, this right here is a valid counterexample.